Check 1, 2. Check. Audio is live. Video is also live. All right. Welcome back. I'm Noctophonics, and today we'll be jumping into a little bit more of JavaScript. Last time we learned about the JavaScript arrays, how to create lists of different data types, and then access those in many different ways with all the built-in methods within JavaScript. So in this episode, if you want to call it an episode, we will be learning about the loops for JavaScript, how to create a function and then run it several times without having to actually write it multiple times. So let's jump into that. JavaScript loops. Gear up and learn loops. This efficient means of automating tasks will make it easier for us to write programs and create games. If you need the same thing done more than once or twice, you could very well take care of that by yourself. When you need something done 10 or even 100 times over, chances are you'll want to create a loop. Loops allow us to repeat tasks over and over. We can also control how many times we choose to loop and what to do with each iteration of the loop. Imagine the waves of enemies you can create, or all the checker pieces on a board, maybe even applying a buff to each member of your team. After learning loops, we'll be able to write programs that automatically take care of monotonous tasks for us, rather than have to hand type each time we need to do the same repetitive task. Cool. Let's do it. Let's learn about some loops. A loop is a programming tool that repeats a set of instructions until a specified condition, called a stopping condition, is reached. As a programmer, you'll find that you rely on loops all the time. You'll hear the generic term iterate when referring to loops. Iterate simply means to repeat. When we need to reuse a task in our code, we often bundle that action in a function. Similarly, when we see that a process has to repeat multiple times in a row, we write a loop. Loops allow us to create efficient code that automates processes to make scalable, manageable programs. As illustrated in the diagram, loops iterate or repeat an action until a specific condition is met. When the condition is met, the loop stops and the computer moves on to the next part of the program. Check out the diagram. So here they have set for us. The start point is hungry, right? If you're hungry, then it loops to eat. Then it loops to, are you full? And then if it's yes, then you're good and it breaks the loop, which is the stop condition. If you're not full, then you eat once again. So the condition of hungry gets you into the loop begins, and then whenever you're full is the stopping condition for the loop. Repeating tasks manually. Before we write our own loops, let's take a moment to develop an appreciation for loops. The best way to do that is by showing you how cumbersome it would be if a repeated task is required you to type out the same code every single time. Create a variable named vacation spots and assign its value to an array of 3 strings naming places you'd like to visit. Write your code below. Okay, so we do constant, right? Constant variable, as we learned last time. Arrays written as constant variables. The array itself cannot be changed to a different data type, but the data types within that array can. Vacation spots they want us to do, because items within an array, or elements I should say, are mutable. So to create an array, like we learned yesterday, we'll put down our brackets and then put 3 places we'd like to visit as strings. So let's just say Hawaii, right? New Zealand, and Ireland. Okay. Next, console log each item in vacation spots. Since we don't know loops yet, we have to console log each element in the array separately. Okay, so I think this is actually possible on one line, even with the information that we know currently. So we just need to console log the variable, and then give it, basically assign it an index number, because as we learned with arrays, each of these has an index number, and they are 0 index, so the first item would be index 0, second would be 1, etc. So vacation spots, we'll do Hawaii first. And there's, I think, oh yeah, you have to console log each one. So then what you would do here, what they're expecting you to do, is 3 of these, 3 lines of console logging for each of the indices like that. So Hawaii, New Zealand, and Ireland. There is a way, we found a few ways to do it on one line. That's sort of irrelevant now, but you could do it where you're joining together everything. So you could call a join method and then add in an empty set of quotation marks. And then that way you would have everything on one line. So you don't actually have to call them all with the join method. Yeah, but if you didn't know about the join method, then you would have to do it on every line. Nice work. Now imagine imagine that the vacation list had 100 places on it. Logging each array element to the console by hand would be a tedious task. In the next exercise, we will learn how to make things more efficient with for loops. Yeah, once again, even if you had 100, you could just do the .join method, like 3 J's there, join method, and then add in that space, and then whatever's inside of the join, whatever is the join argument, the argument for that method, it will be added after after each element in the list in the array. But anyway, there will be another way to do it in the for loops. The for loop. Instead of writing out the same code over and over, loops will allow us to tell computers to repeat a given block of code on its own. One way to give computers these instructions is with a for loop. A typical for loop includes an iterator variable that usually appears in all 3 expressions. The iterator variable is initialized, checked against the stopping condition, and assigned a new value on each loop iteration. Iterator values or variables can have any name, but it's best practice to use a descriptive variable name. A for loop contains 3 expressions separated by semicolons inside the parentheses. An initialization starts the loop and can also be used to declare the iterator value. A stopping condition is the condition that the iterator variable is evaluated against. If the condition evaluates to true, the code block will run, and if it evaluates to false, the code will stop. An iteration statement is used to update the iterator value on each loop. The for loop syntax looks like this. So if they ordered these in the order that they appear in the for loop, then the initialization is this first part of it, then the stopping condition, and then the iteration statement, which is basically the code that runs before if the stopping condition is not met. So the way that it looks like you just put in a keyword for or if, like we're almost doing a conditional there, which it is kind of like a conditional, but a conditional that loops. So for keyword parentheses, the first initialization, which is saying let counter equals 0. This establishes a variable and assigns it a value. Then the stopping condition, they want this to stop when the counter is 4 or more. So if the counter is less than 4, this code will still run, and the code that runs is counter plus plus. This is the iteration of the loop itself, and then the code that runs inside of that is to console log the counter. So in this example, the output would be the following. So it would output the numbers 0 through 3, and then once it reaches 4, it would stop. It would see that the counter is not less than 4. The iteration, the counter would not increase, and also the counter would not be logged. So basically, it's sort of like we can remember with an if-then statement that runs multiple times. or if else condition, but you have two things that are running even if you just have one line of code in there, because the iterator is running as well. Let's break down the example. So I think I went through, yeah, we went through all of that. This for loop makes it possible to write 0, 1, 2, and 3 programmatically. Cool. Now make your own. Create a program that loops from 5 to 10 and logs each number to the console. Okay, so let's do for, and we'll keep the same sort of syntax. So we're going to say let counter equal, so from 5 to 10, so let counter equal 5 semicolon. That'll be our initialization. Then we want our stopping condition. So counter variable is less than 11, so that if it's equal to or greater than 11, this will stop. And then we want the counter to increase. And then inside of this, we'll console log counter. So now, as we run it, let's see what happens. So counter needs to be spelled correctly. There we go. Voila. 5, 6, 7, 8, 9, 10. And then it sees that it reaches 11, the counter variable does, so it does not log the counter to the console. Now, if you didn't have the iteration, right, then the counter would always be less than the stop condition. It would always be less than 11. And therefore, this code would run indefinitely, right, to infinity and crash your computer. Or it could. I think there are some stop gaps for that in CodeCademy. But yeah, if you don't put in either a stopping condition or an iteration, if the stopping condition is always true or always not true, always false, then the code would run indefinitely. Looping in reverse. What if we want the for loop to log 3, 2, 1, and then 0? With simple modifications to the expressions, we can make our loop run backward. To run a backward for loop, we must set the iterator variable to the highest desired value in the initialization expression, set the stopping condition for when the iterator variable is less than the desired amount, and the iterator should decrease in intervals after each iteration. We'll practice by changing the for we wrote previously to now go in reverse. When writing or changing loops, there is a chance that our stopping condition isn't met, and we get a dreaded infinite loop, which essentially stops our programming from running anything else. And that's when things crash, when things hit, one of the reasons why things crash is things hit an infinite loop. To exit out of an infinite loop in an exercise, refresh the page, then fix the code for your loop. Make a for loop that loops backward, printing 3 to 0 to the console. Use the greater than equals comparison operator in your stopping condition and the minus minus operator in your iteration statement. So first we want to have the counter equal 3, because we want that to be the first thing we're printing to the console, and let the counter equal greater than or equal to, I guess this would be -1, right? If the counter is greater than or equal to, oh, I see, no, 0 is fine. If it's greater than or equal to 0, then it will stop. Greater than or equal to 0? But it is greater than 0, right? It is greater than 0, so I think that would stop already, but it says they want us to use that. So let's try it. So minus minus, so what will happen here? The counter will log 3, or will it? Because it sees that the counter is greater than or equal to 0. Edit it to loop it backwards from 3 to 0. So I don't think it will run at all. I don't think this will run at all. Oh, it will. Okay. That's interesting. Greater than or equal to 0. Oh, right. Yeah. So if this is true, right? Counter is greater than or equal to 0, then it will run. I think I was thinking of that backwards, trying to run a backwards loop. So, yeah, so if your stopping condition is something like is greater than or equal to a value, it will run if indeed that value is above what we set for it. So sweet. So now we have a countdown. 3, 2, 1, 0. Looping through arrays. Ah, yes. For loops are very handy for iterating over data structures. For example, we can use a for loop to perform the same operation for each element on an array. Arrays hold lists of data, like customer names or product information. Imagine we owned a store and wanted to increase the price of every product in our catalog. That could be a lot of repeating code, but by using a for loop to iterate through the array, we could accomplish this task easily. To loop through each statement in an array, a for loop should use the arrays.length property in its condition. Check out the example to see how for loops iterate on arrays. Constant animals equals grizzly bear, sloth, and sea lion. For, so they establish their loop there, let I, this can always just be a random letter or whatever you want, let I equal 0. That's just establishing the variable. I is less than animals.length I plus plus. So as long as I is less than the index length of the array, it will keep running, and it will console log the index or whatever is at that index number of the array. Pretty cool. It's kind of brilliant. This example would give you the following output: grizzly bear, sloth, sea lion. In the loop above, we named our iterator I. I think they're just explaining what I just explained, so I'll move on. With for loops, it's easier for us to work with elements in arrays. Yes, indeed. Sweet. Yeah. Write a for loop that iterates through our vacation spots array using I as the iterator variable. Inside the block of the for loop, use console log to log each element in the vacation spots array after the string I would love to visit. For example, the first round of the loop should print I would love to visit Bali to the console. Okay, cool. So for, put in this, we'll do the same letter, like I for index, right? So I equals 0. And then I is less than the vacation spots.length. And I gotta separate these with semicolons. And then the last one is I plus plus. I plus plus. Inside of this, we want it to console log a string. And the way we can do this, we can do concatenation, but I think let's do interpolation instead. So use your backticks instead of your quotation marks. So I would love to visit needs to be at the first part. So I would love to visit. Make sure you put a space after visit, so it will indeed add one. $, curly brace, and put in vacation spots with the index of I. So then as this function, or it runs like a function, as this loop runs its code, it will look at I, what I currently is, and then console log that to, log that to the console. And then I will change, and then it will console log it again. And we will have, I would love to visit Bali, I would love to visit Paris, and I would love to visit Tulum. Not sure where Tulum is. That's interesting. Cool. Nested loops. Oh, we're getting complicated now. When we have a loop running inside another loop, we call that a nested loop. One use for a nested for loop is to compare the elements in two arrays. For each round of the outer for loop, the inner for loop will run completely. Let's take a look at an example. So they have two arrays set up, my array and your array. Let's see if we can keep track here. So for let I, they're setting up the first for loop like we did in the previous exercise. I equals 0, as long as I equals less than, or is less than the length of the first array, it will iterate, and I will increase. And then inside of that for loop, they have another one that accesses in the same way the second loop, or the second array. So they use the variable of j. They said as long as j is less than the second array's length, j will increase. And then inside of that, it'll say if my array and the index equals your array and its index, then console log both arrays have the number your array. Oh, that's clever. Yeah, okay. So if you want to have two arrays that compare each other, and in this way, I don't know what practical application that would have with like the specific index number, but it could. So if your number at array, if your number in the first array at 0, at index 0, is the same as the number in your second array at index 0, then it will console log that both arrays have the same number. It won't console log anything with this specific case because none of the, there's 19 repeated, but they're not at the right index to be compared, because it's saying, okay, so my array index 0 equals your array index 0, right? So those will never match up and nothing will be logged to the console. So I think we thought about what's happening inside. Now it's your turn to write a nested loop. To exit out of an infinite loop in an exercise, refresh the page, then fix your code for your loops. Yeah. And if it happens outside of CodeCademy or your code editor, restart your computer because you most likely have crashed it. Imagine you're a bigwig programmer for a social media platform. Woot. You have been tasked with building a prototype for a mutual followers program. You need two arrays of friends from two mock users so that you can extract the names of followers who exist in both lists. Make a variable called Bob's followers and set it equal to an array with 4 strings representing the names of Bob's friends. All right, Bob, let's give you some followers. Let's see. So I don't know if this should be constant or maybe, I don't think we'll change it. I think we're just referencing it. So I think it can be constant. Also with an array, you can change the elements within an array. Bob's followers. And let's give Bob some followers. Let's say some random names, Marcy, Jenna, Toto, and Zerubbabel. Okay. So those will be Bob's followers. He's got 4 so far. It's okay, Bob. Everyone has to start somewhere. Make a variable called Tina's followers and set it equal to an array with 3 strings representing the names of Tina's friends. Make exactly 2 of these the same as 2 of the friends in Bob's followers array. Okay, so Tina's got some followers too. She's also streaming on Twitch. Tina will only have 3 though, not 4. Bob's doing a little bit better than her. Must be streaming some more Fortnite. Tina's followers, Jenna, Toto, Zerubbabel. So let's say Marcy, right? Marcy. I don't know that they need to be in the same order, so let's put in Zerubbabel as a string. And then Toto will be, or I guess the last one can be unique, right? So let's say Gillian. Okay. Create a third variable named mutual followers and set it to an empty array. All right, so mutual followers. Set that equal to an empty array, just like so. Create a nested loop that iterates through Bob's followers as the array for the outer loop and Tina's followers as the array for the inner loop. If the current element for the outer loop is the same as the current element from the inner loop, push that element into the mutual followers array. So maybe the order does matter. That's interesting. At least with the example that they showed us, it compares what is at a specific index for each array. These 2, let's see. What's the array for the outer loop, Tina's followers? Yeah, okay, but we can still do this. It'll just print Marcy, I believe, when we finish. Let's start our first for loop. Let's just use the letters I and J, like they did in the example. I equals 0. That's the initialization. Let's put in our stopping condition I is less than, and we want Bob's followers first, so Bob's followers dot length, and then as long as that is less than the length, we will iterate the I positively. We will increase it. Inside of this, we'll then put another for loop. This will be for Tina. We'll give her the variable of j equals 0, and j is less than Tina's followers dot length. Once again, we'll iterate it the same way, so we'll add 1 to it each time it runs. Inside of this, we will then compare followers. So we needed a conditional. If Bob's followers and the index of I, because that's what's being compared to the Bob's followers length, index of I is equal to, so 3 equal signs, Tina's followers of j, then we will log or add that result into mutual followers. And the way that we're going to do that is with our push mutual followers dot push. And let's see, so how do we want to reference what it is? Push that element into the mutual followers array. So how do we say, is it just like, because the condition is seeing that it's the same. But now how do we take that value and put it into the push? Mutual followers, that array. Because we couldn't just put like a variable that it's been using, right? We could just use like Bob's or Tina's followers. I think there would be another way to do that, but at the moment, let's try Bob's followers and then the index of I, because that should work every time. And then we'll also want to console log that as well. We could do it on the same line, but just console log mutual followers. We might change what we're doing in the first line. Marcy and Marcy and Zerville. Okay, so that worked. That's interesting. That is very interesting. So it logs Zerubbabel even though it's not at the same index. Because with this code, it should look at 0 for both and say, okay, those are equal. And we're going to push Bob's followers to that. Then it looks at 1 and says, okay, these aren't equal. It looks at 2 and it says those aren't equal. Then it looks at 3 and J stops. So it looks at 3, for Bob. This comes out undefined though. So I don't know, if I change this, is this going to log instead of Zerubbabel? No, it doesn't. So if you console log mutual followers at the end, it just prints out Marcy. But why when you put in, it console logs twice? Index equals that. I don't know why it's pushing that, because it should just compare the index, the specific index that you're at. Let me see if I can gather any more from the example they gave. For each element in the outer loop array, my array, the inner loop will run its entirety comparing the current element from the outer array, my array I, to each element in the inner. Oh, I understand now. Okay. Yeah, that makes more sense. And that's more thorough too. That way you can compare values without having them have to be at the exact index as the first array. That makes way more sense. Okay, so for every time that the outer for condition is met, or the stop condition is met, then this loop runs in its entirety. So J will iterate through every index of the Tina's array or Tina's followers, and then it will move on to the next index of Bob's followers. So basically, it's kind of like numbers counting up, right? Where you have, or the places of numbers. So this is kind of like the single digits place. This is the tens place, right? The ones and tens. So once you go 1 through 9, right? Once you get to 9, then or 0 through 9, once it flips it back over to 0, then it runs the next number, if you will, on the top. So yeah, that's interesting. So just, you can kind of think of it like if you were counting up digits, and it's the next digit place over. That's cool. Cool. So that's why Marcy and Zerubbabel popped up at the end. So this runs its full length, right? So for Marcy, it runs and sees that we have Marcy. Then it does at space 2 and sees if we have Jenna through all of those. None of those are Jenna. Then it sees if any of those are Toto. None of those are Toto. And finally, it sees if any of those are Zerubbabel, and that is a match. So then it adds Zerubbabel to the mutual followers and logs it again. And the reason why there's 2 console logs is because this runs completely every time the stop condition is met here. Okay, cool. Sweet, let's move on. You're doing great. We're going to teach you about a different type of loop, the while loop. To start, let's convert a for loop into a while loop. A for loop that prints 1, 2, and 3. For let counter 1 equal 1, let counter be less than. For counter 1 plus plus, console log counter 1. A while loop that prints 1, 2, and 3. Let counter 2 equal 1. While counter 2 is less than 4, console log counter 2 plus plus. So it appears relatively similar. The syntax is just a little bit different. Let's break down what's happening. So the counter2 variable is declared before the loop. We can access it inside our while loop since it's in the global scope. We learned about scope 2 days ago, I think, on Monday. We start our loop with the keyword while, followed by our stopping condition or test condition. This will be evaluated before each round of the loop. While the condition evaluates to true, the block will continue to run. Once it evaluates to false, the loop will stop. Next, we have our loop's code block, which prints counter 2 to the console and increments counter 2. Okay, so sort of trying to spot the nuance of difference here. So with counter 1, we saw how this works before. So in the while loop, this is the stopping condition, but the variable is set outside of it. I guess this could be useful if you have multiple loops accessing the same variable. So you'd create while loops to access that without having to establish new ones. Yeah, then it console logs it and increments it. So you may be wondering why or when to use a while loop. The syntax of a while loop is ideal when we don't know in advance how many times the loop should run. Think of eating like a while loop. When you start taking bites, you don't know the exact number you'll need to become full. Rather, you'll eat while you're hungry. That's a great example. In situations when we want a loop to execute an undetermined number of times, while loops are the best choice. That's interesting. Although we would know just by doing you know, a simple calculation when or how many times this would run. But yeah, while loops are better for when you don't know how long it should run. All right, below the cards array, declare a variable current card with the let keyword, but don't assign it a value. Okay, so just let current card. Oh, I see. Okay, I think I see what they're doing. So current card, make that camel case. All right, create a while loop with a condition that checks if the current card does not have the value of spade. So while, and then current card. Is equal to 3 equal signs there, is equal to spade. Then we'll run inside of the block, add the following line of code. So current card equals cards math.floor.math.random. Okay, so then it's going to assign you a new card if you don't have a spade. And remember, so the stopping condition or the testing condition, that might be easier to think about at this moment. When this evaluates to true, the code runs. Once it's false, then it will stop. So the stopping condition only stops if it evaluates to false. Math.floor.math.random gives us a random number from 0 to 3. We'll use this number to index the cards array and assign the value of current card to a random element from that array. Nice, that's clever. So since there are, did you check if current card is equal to spade? Current card is equal to spade. Should be correct. Did I have that backwards? While current card equal to spade. Yeah, it looks correct. Let's see. Current card equals cards math.floor math.random times 4. All good there. Checks if it does not have a value of spade. There we go. Okay. So it's still, what I said earlier was still correct in that this, if it sees that it's not spade, it's going to change the card, right? So whenever this is true, whenever the stopping condition is true, the code inside of the loop will run. Once it evaluates to false, then it will stop. But with this, we want it to run if it's not spade. If it is spade, then we want it to stop. So that's why we put in that bang operator, the exclamation point, before our 2 equals sign. Awesome, your loop is running. But you can't tell because it doesn't output anything. Let's add a console log to our while block. Inside the block, after you assign current card a new value, log current card to the console. Easy enough. Console log current card. For fun, you can run your code a few times and see how the output changes. So we got spade off the bat the first time. Let's see. Aha, yeah, see. So this is basically you hacking the game of cards, right? Whatever card game you're playing, you're like, I will get spades. I will always get spades. So while I don't have spades, I'm going to run code until I get spades, and I will eventually have a spade. In this case, it took 1, 2, 3, 4, 5, 6, 7, 8 iterations of this. And once again, while loops work great when you don't know when it's going to stop, or when you want to sort of randomize that. Yeah, so this is good for like a loop that also has some degree of randomness in it. Diamond, 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 club, club, spade. Yeah, like this one. See, it can take several attempts before it actually reaches that. With the for loop, you would have to program in like specifically when you wanted it to